So things to be ready for. In section 1.2, one of the things we talked about was voluntary response. And the problem with voluntary response is that your data is no longer representative of anything but the people who happen to choose to respond. So that's kind of a big problem. You might want to look at problem number 32 in section 1.2. Also be aware of the difference between the census and a sample. Census means you're polling or finding data from everybody in your population. A sample means it's just a subset. So it can be a real good subset, but it's still a subset, so be a census. We looked at different types of data: nominal, ordinal, interval, and ratio. Ratio was something that had a 0, so it would make sense to talk about something being twice as much. I would not make you calculate a standard deviation from frequency data, but we did calculate the standard deviation from, or we calculated the mean from frequency data. And that formula is right here. You just take the sum of your x's times f divided by the sum of the f. Basically, summing up your data, the sum of the frequencies is going to be your count. In histograms, one of the things we looked for was a histogram that had a normal shape. What's another name for a normal shape?
Bell shape.
Bell shape, right? And there was a couple ways you could look for that. One thing you want to make sure of if your data wasn't normal or was normal is that it didn't have more than one outlier. The skew of your data is which direction it goes. We looked at some measures of central tendency. Those would be mean, mode, median. The bummer thing about the mean is that it is sensitive to outlying values. The good thing is that it uses all your values. The mode ignores some data, but you can use it with nominal data. It's the most frequent. And the median, which also goes by the name of Q2, is just your midpoint. The nice thing is that it's not sensitive to outliers, but it, again, doesn't use all of your data. You should have a basic understanding of probability. Probability of 1 was that something that was certain to happen. Death and taxes is the famous one for that one. Probability of the Lions winning the Super Bowl is closer to here. All right, so those are subjective probability. More into probability, A and B are disjoint. There's another name for disjoint, and that is mutually exclusive. I tend to prefer this one because the word sort of reflects what's going on here. One excludes the other. They each exclude each other. If you're heads, if you flip a coin and get heads, you can't get a tail, and vice versa. We spent some time in section 4.3 with the general addition rule. And we moved on to discuss independent events. Independent events mean that the probability of one doesn't affect the probability of the other. So rolling a dice and tossing a coin, the outcomes you get from those are going to be independent. Now I have some suggested problems if you actually take a look at these. Suggested problems to look at. So in section 4.4, that would be these down here. In 4.5, we looked at the complementation rule. So that was this one. We used that to good effect in calculating some probabilities. And then in 4.6, we spent some time with counting rules. So N choose R and N PR. The big difference is one of these order matters and one of them order doesn't matter. And which one does order matter? Good. Order matters. And my sheets got mixed up, which is why I jumped a little bit. You should know what the variance is. variance and the standard deviation. We don't use the variance too much. There are some tests later for variance, but it's kind of getting at the same idea. Standard deviation reflects how spread out your data is. Now, it depends on whether or not you're talking about a sample or a population. Sample variance is denoted with an S. Population variance is denoted with a sigma. So S squared or sigma squared. One is just the square root of the other in terms of going from the variance to the standard deviation or vice versa. Standard deviation is always greater than 0. Now, with the standard deviation, we had what was called the empirical rule. Most of your data is going to be within one standard deviation, 68%. An even greater portion of your data is going to be within 2 standard deviations, 95%. And then almost all of your data is going to be within 3 standard deviations of the mean. Now, the empirical rule applies if your data has what kind of shape? Yeah. Bell-shaped data. So you should be able to find how many, 1 or 2 or 3 standard deviations away from the mean, depending on what I ask you. Now, more than 2 standard deviations away from the mean means things are an unusual observation. So again, I've got some suggested problems. The last section that we covered in Chapter 3 talked about measures of relative standing. We looked at a box plot briefly. Box plot goes from the minimum to the maximum, and then the shoulders in this line here are the quartiles. One thing that I will be asking you is the difference between something like this, 23rd and 77th percentile. If you were getting your results back from the SAT, where would you want to be, in the 23rd percentile or the 77th percentile? 77th, because that means that 77 people are below you for every 23 people that are above you. So make sure you have those two straight. That's a calculation that you can again do on Google Sheets. We're not going to spend time on the actual calculation itself, but on the understanding. So make sure you know the difference between those two. Whew. All right. So 3 weeks worth of statistics in 7 minutes. Pretty good. Good luck. I'll try and get in here a little bit early on Wednesday to help you out. See ya.